Okay. All right. If you open that RMD file in structural form, guys, there are several packages there. So maybe I suggest that you install those packages that you don't have yet. I think yung Broom meron na tayo, car, I'm not sure, core plot, forecast. Anyway, I'll give you some minutes. Stargazer meron na tayo, o LSRR meron na. Mas, I'm not sure, LM test. So kindly install this, okay? And I'll give you 1 minute for that. And then we go to the first, the RMD file we were working on last time. If you're done, guys, with the installing the packages, kasama naman yata yung scheme R dun, ano? Okay, pati itong...
Sir, you're not showing art still on the website.
Oh, sorry.
Thank you.
Okay, thank you. Okay, can you see it now?
Yes po. Thank you, sir.
Okay, thank you. So I'm on the OLSRR markdown file. we worked on this last week. We started working on this. So just kindly include sa installation ng packages yung meron tayong site, yung scheme R, sinama ko yata dito si scheme R. Scheme R here. Wala, hindi kasama si scheme R. Okay, dito natin gagamitin si scheme R. Okay, and then kindly import na yung wage interact file natin. Sige, I'll give you a few, maybe a minute to make sure that the data set has already been imported. Are you done? Have you uploaded imported the wage interact data set? The one we were working on last time? Ngayon guys, magre-request ako kasi in the interest of time, talagang kulang na tayo sa oras. Pakisagot na lang pag nagtatanong ako kasi baka tapos na kayo tapos naghihintay ako sa kawawalan, ano? So kung hindi pa, sabihin niyo sa akin para I'll give you more time. Pero pag tapos na, pakisagot na lang para makapag-proceed na tayo kasi I surmise that we were wasting some time by you not replying. So kung pwede, tatanungin ko ulit kayo guys ha. Meron pa bang hindi tapos sa sa pag-upload ng file ng Wage Interact? Sino hindi pa tapos? Tapos na ba kayo?
Tapos na.
Done, sir.
Ha? Okay na?
Done, sir.
Okay, done. Okay. So wala nang hindi pa tapos ha. All right. So if we get the structure, so kung na-import nyo na yan, dapat makikita natin yung file natin, wage interact. Remember, this was the file that we use in Excel. We were regressing wage on these variables, which consist of number of years of education, number of years of experience. Tapos may mga categorical variable tayo na female, non-white, non-union, plus some interaction variables. Okay. So here we're going to regress. We did this in Excel. We did this with yung real stat na add-ins dito sa R natin ginawa, no? Okay, so tingnan muna natin yung structure niya. I'm going to just run this line by line. Asan na? Okay, structure. Okay. So we have a table, 1,289 rows. Okay, and we said that ang medyo concern natin dito si female, non-white, non-union are treated as numerical variables. We know that they're ones and zeros, but they are categorical variables. No factors sila. So ayusin natin yan. Okay. Another way to describe your data is using the describe function from the psych package. I also like this, yung describe na to kasi binibigay niya, for example, yung skewness, yung ba't bumagal yung ano? Kanina mabilis to. It's taking a long time to run the code. Okay, so ito yung output dun sa describe. This comes from the psych package. So it gives us some very important statistical measures: median, standard deviation, mean, minimum, maximum. This is the range, the difference between the mean and the max, skewness, kurtosis, and standard error. Okay, may ano tayo dito, data na hindi naman kailangan, si observation. Okay, pero hindi naman natin gagamitin yan sa regression natin. Tapos si female, non-white, non-union, they are, as we said a while ago, they are treated here as numerical and we don't want that. And lastly, si skim, guys. Ano naman si skim? Skim is from the skim-R package. This is also a good package for, for descriptive statistics. Bakit ang tagal? Tagal na mag-run. Rinrun nyo ba guys yung ano? Yung naran nyo na yung skim?
Yes.
Yes,
Is
sir.
it taking you long?
No,
Okay,
sir.
Bakit ang tagal ng pag-run ng ano ko? Ng R? Okay. So ito guys, yung skim, binibigay sa atin yung data summary, yung name daw ng data set, ilang observations, ilang columns, kung may group variables ba, none. Tapos, it gives us also some important information like ilan yung missing. Wala naman daw missing sa mga variables natin. And then yung mean nila nabigay, although walang significance yung mga mean itong factors na to, no? And then you have the minimum value, first quartile, median or second quartile, third quartile, and the maximum. And parang a small diagram of the histogram of the variable. Okay, so dito nakita natin, we saw two ways of generating your descriptive statistics. Okay, may iba pa guys, pero I'll just show you two of my favorites, si describe at saka si skim. Okay, sabi natin, we said a while ago that female, non-white, non-union should not be numerical variables, but they should be categorical in the form of factors. So we're going to change them. Okay, so wage interact, yung female, dapat factor siya, etc. Okay, so let's run this. And yung structure ngayon ng wage interact. Tagal na. Okay. So what happened here? So si female, non-white, non-union, ano na siya, no? factor. And that's what we want. The rest are numerical. Itong mga interaction variables natin, numerical yan. Kasi pag nag-multiply tayo ng numerical at saka ng categorical or factor, magiging numerical yun. Alright, any questions so far, guys? Please answer.
None, sir.
Answer.
Alright, thank you. Okay, so na-convert na natin yung categorical variables natin into factors. Now, what we did last time, we said that there are, sa regression, hindi pa pwede yung nag-regress tayo ng 11 independent variables, tapos pag may mga insignificant, tapon na lang natin yon, tapos yung matitirang significant, yun na yung model natin. Okay? Hindi pa pwede yun kasi dapat mag-stepwise tayo. Kasi baka may mga tinapon tayong variable doon na significant after all. Okay, so that's the problem if we just throw them away. Kasi minsan, because of multicollinearity, hindi nagiging significant yung variables na yun. So one way to do that is to do stepwise regression. Sabi natin, basically, there are 3 types of stepwise regression. Una, yung forward regression, where you start with from a zero slate, wala kang variable, tapos ipapasok mo isa-isa yung variable. Once pumasok yung variable na yon, hindi na pwedeng tanggalin yon. Okay? And then we have the backward regression where you start with the whole set of your independent variables being regressors. And as the name suggests, backward siya, iisa-isahin natin tatanggalin yung mga variables na hindi significant based on the p-value of 0.05, no? Tapos ang leaving LEAVIANG, yung unang natatanggal, yung highest probability p-value or the lowest absolute value ng t-stat. Until you reach such a time na wala nang insignificant. Tapos parang forward din siya, oras na once you remove a variable, it cannot go back. Okay? And then the third method is the stepwise regression. This is a combination of forward and backward. It starts like a forward regression kasi zero slate muna. Wala munang regressor. Then isa-isang ilalagay. No? Ngayon, sa stepwise, pag nalagay mo na siya, pwede mo siyang tanggalin ulit. Unlike yung forward. Once inside, once part of the model, hindi mo na pwede matanggal. In other words, in chess parlance, no? Touch move yan sa forward, pati sa backward. Pag pinasok mo siya, forever, pasok na siya. No? Pag tinanggal na siya sa backward, forever, tanggal na rin siya. Sa stepwise, walang touch move. Pwede mong tanggalin yung pinasok mo, okay? Pwede mong ipasok yung tinanggal mo. No? So ganun 'yon. Alright, so we started last time with the forward regression. Ang ginamit natin yung p-values. Ang criteria natin dito, yung entering variable, dapat, ang i-contribute niya, dapat magpi-p-value siya na 0.05. Otherwise, kung mag-enter ka ng variable tapos hindi siya 0.05 yung p-value niya, hindi pa pwede yan. Okay, take a look at this, guys. Ito yung model natin, ano? Asan na? Dito. Alright. Ang model natin is ito. We call it model. Of course, you can use another name for that. Then we have this linear function, linear model. Then our dependent variable wage regress against the 11 dependent variables using from the data is equal to wage interact. Okay. Now, kung kasama lahat ng variables, hindi mo naman kailangan isulat kasi may shortcut diyan. Ang shortcut, okay, kindly just insert this in your mag-insert na lang kayo ng code na ganito. So pwede yung gawin to, no? Shortcut if all the IVs are included, LM wage tilde then dot. Then comma for the data set where you're getting it. Ibig sabihin nitong dot, guys, lahat ng variables na ando dun sa data natin. Okay? Now, we didn't do it a while ago kasi meron palang observation dito. Kung natanggal natin yan, which we should have done, ano, pwede natin gawin yung code na yon na tilde tapos dot. Gets, guys? Clear? Feedback, please.
Yes, sir.
Yes, sir.
Yes, sir.
Thank you. Thank you. Yung iba pakasagot din ha. Tatatlo lang narinig kong sumasagot. Okay, so we're not going to do this kasi dapat tinagal muna natin yung observation. But anyway, just bear in mind guys na pwede ito. So sometimes it's best na yung model na yung data na ipapasok mo, lininis nyo na muna. Kasi ito hindi natin lininis. Sana tinanggal na natin yung observation muna bago natin sinave as CSV file. So anyway, that's one lesson learned. Para pag regress natin, tilde, dot na lang. Kasi alam natin na lahat naman yun ipapasok natin. So ito na lang sana. No? Kaso may ano tayo doon, may observation. So papasok yung variable na observation, which I don't want. Huh? Kasi hindi naman siya talaga variable. Alright, so ito yung model natin, LM model natin. Sinama natin lahat ng mga regressors natin. Okay? Notice guys, medyo mabilis na ako dito kasi nagawa na natin to. Parang review na natin ito. And then we're creating an object called forward fit.p. Okay? So again, arbitrary yung pangalan to guys. Para sa akin, maganda kasi forward yan, tapos nag-fit tayo using p. And then the code is OLS stepwise regression. Okay? And then forward, then p. And then we use anong i-ano natin, i-forward natin, yung model natin, which is this one. And then p, yung entering variable dapat 0.05 yung yung p value. Let's run this. Okay? So when we run this, magge-generate siya magge-generate niya yung FW. Naran ko na kasi kanina from the other class. So forward fit.p, generate niya, ano? You follow, guys?
Yes, sir.
All right. Then,
Yes, sir.
Okay, thank you. Then, i-run na natin siya. Na-generate pala yung object na yun, pero hindi pa natin napapaprint. Pa-print natin siya kay R. Bagal. Okay, so this is the output. This is forward regression using p-value. So ano yung kwento nito? Yung unang step ang linagay si education, okay? Then second step, third step, fourth step, fifth, sixth step, okay? Even sa ating AIC, okay? Sa sixth step, guys, ang dinagdag si non-union, and we can be sure that itong non-union na to in all of these variables, in this whole model, yung p-value niya is less than 0.05. And we know that because we have done that. No? Now, hindi pinasok si female dito, unlike yung isang model natin, pinasok si female. Bakit? Kasi pag pinasok natin si female, yung p-value niya magiging 0.09. Okay? So let's experiment lang guys. No? Gawin natin tong 0.10. What if yung yung criteria for an entering variable is 0.10? Subukan natin i-run. So run that. Okay. And then run. Okay, what do you notice, guys? Ano nangyari?
Nadagdag si female, sir.
Yeah, nadagdag si female. Kasi, sabi natin, ipasok mo yung variable for as long as less than 0.10 yung ano. In other words, ang level of significance natin is 10%. Yung alpha natin is at 10%. Kaya si female, kasi alam natin ang p-value niya 0.098. Pumasok siya. Okay? Clear yun, guys?
Yes, sir.
Okay,
Yes, sir.
ibabalik ko lang yung point ibabalik ko yung level of significance sa 0.05. Okay, just to be consistent with the other class. Okay, run ko ulit to. Okay, run ko ulit. All right. So sabi natin, there's another way, another method na forward regression, this time using Akaiki. Si Akaiki naman yung magiging benchmark natin. So using the same model, okay, Although hindi na natin kailangang isulat to guys, kasi anyway, existing pa yan. How do I know that model is still, that object is still existing? Andito pa siya, no? Ayan pa yung si model natin. Alright, so forward fit.aic, pareho din yung ano yung code sa OLSRR, OLS step forward, this time AIC, then model. Then we have now FW fit.aic. So that model is, that object is existing. I-run natin. Okay. What do you see, guys? Ang selection summary niya, for as long as, pag remember forward to So sa forward, dagdag tayo ng dagdag, add, for as long as the AIC is dropping, okay lang. Pag nagdagdag pa tayo, tapos umangat na si AIC, stop na doon. No? Hindi na isasama yan. So, this is the selection summary. So, una pinasok si education, and it's the same. Actually, pareho lang siya dito sa ano sa forward P. Ang kaibahan nga lang yung total variables na sinama. Dito hanggang non-union lang, dito pinasok si female. Kasi nga, iba ang criteria dito. Ang criteria dito, for as long as bumababa yung AIC, ipasok mo pa rin. Dito naman, for as long as 0.05 yung P, ipasok mo. Okay, so you notice that there might be different criteria. But it's okay, guys. No? Kasi candidates pa lang naman sa model natin yan. Remember, nagmo-model selection pa lang tayo. Hindi pa to yung, yung final model natin. Okay, hindi pa tayo mag-generate na equation dyan. Kasi whatever model we're going to choose, dapat dumaan yan sa diagnostics. Ano ibig sabihin ng diagnostics? Chinek dapat natin yan for multicollinearity. Chinek natin yung residuals for heteroskedasticity. Chinek natin yung yung outliers. Chinek natin yung influence points, yung leverage points. Chinek natin dapat yung normality ng residuals. Okay? So dadaan dapat yan sa diagnostics. It's not enough. Kumbaga parang QC yan, quality control. Andiyan yung product, no? Tingnan kung baka defective yan, no? So kung defective yan, baka another model will suffice if it violates the assumptions of classical linear regression model. Okay, so dito sa forward AIC, for as long as the AIC keeps on dropping, ayan no, baba ng baba, 86, 88, 85, 76, hanggang 84, 83. Pag nagdagdag ka pa dyan, tataas na yan. No? So, that's why, dinap na doon. Okay, clear guys? Clear?
Yes, sir.
Yes, sir.
Yes, sir.
Yan,
Yes,
salamat
sir.
ha. Salamat, pakisagot ha. Okay, then pwede natin ipa-plot yan visually. Makikita natin kung how the process of forward regression was being generated, no? Ito. Yan. So nagpo-forward, pag forward guys, dagdag ng variable yan. No? Dagdag ng education, dagdag ng experience, dagdag ng fem interact education, etc. hanggang female, no? Okay? Yun ang mga dinagdag na variables based on AIC. Pag nagdagdag pa ng pang-walo, wala na. Tataas na yung AIC. So, nag-stop na siya dyan. Okay? So, ito, a plot of the AIC together with the AIC kung dinagdag yung variable na yan. Kung education lang, ang taas ng AIC. Sayang yung mga regressors. Nagdagdag tayo ng experience, gumanda. Bumaba yung AIC. Bumaba, hanggang female, pag dinagdag pa natin yan, tataas na. Clear, guys? Clear?
Yes, sir.
Yes, sir.
Okay, thank you. Then, paano to? Ngayon, ito, pareho lang ng code yan sa taas, guys. Dinagdagan lang natin ng details. Yung details, magpapakita sa atin ng step by step kung paano niya ginawa yung forward regression using AIC as the basis. So, let's run this. Okay, so it will take a few seconds. Kasi mahaba yung process niyan. Okay, we looked at this last time. So take note, forward selection method. Ito yung mga candidate terms natin, yung 11 independent variables. Okay, ang forward regression guys, sabi natin, nagsisimula yan sa step 0, okay, na ang regressor natin, 1. Ang ibig sabihin ng 1 dito guys, walang regressor. Okay, hindi ibig sabihin na ang number na 1 yung regressor natin, hindi. It's a symbolism guys, ibig sabihin, walang pinipiling regressor. In other words guys, ano yung model na to? It's just the average of your wage. Okay? Hindi tayo gumamit, naalala nyo dati yung saan natin, sa advertisement at saka sa sales. Hindi tayo gumamit ng in this case, hindi tayo gagamit ng regressors. We'll just use the average of Y as the predictor. Okay? Pero is it good? Kasi ang sinasuggest niya, tingnan mo, sabi niya, pag ipasok mo si education, yung 89-88 mo na Akaiki, magiging 86-88 yan. Di ba? So, mas maganda itong may education. And among the candidates, remember guys, yung entering variable natin, 1 at a time yan. Hindi pwedeng dalawa, tatlo. Hindi pa pwede. Okay, isa-isa. So, among the candidates to be entered as a variable, si education ang pinakamaganda. Why guys? Kasi pinakamaliit yung Akaiki yung result na ma-generate pag ipasok natin si education. Okay? That being said, sabi dito, ipasok mo natin si education. So, after the first step 1, ang Akaiki na natin, yung 86-88 na. Okay, nag-improve na to. Ang model natin, wage education. Then again, forward regression. Oh, pag pinasok daw si experience, mas bababa kaysa kay education lang. Okay, kaya pag pinasok naman si new white experience, abay, tataas pa yung AIC, di ba? So what's the point of including this? Tataas yung AIC pa. So pinasok si experience, naging ganito yung model natin, naging ganito na yung Akaiki natin. Okay guys, nakukuha yung kwento. Guys, kwento yan di ba? Hello?
Yes, sir. Yes.
Yes, sir.
Okay.
Yes,
Yung
sir.
kwento. Okay, thank you. Thank you. So hanggang sa dulo yung kwento natin, sabi dito sa step 6, 84-84 na Akaiki, ito na yung regressors natin. Okay? Sabi, pag dinagdag pa natin si female, 84-83 yung Akaiki. Oops! Dito, 84-84. Magiging 84-83 daw. So pwede. No? Pwede ipasok si female. Pinasok si female, pinasok si female. So, naging 84-83 na yung AIC natin. Tapos ito na yung model natin. Kasama na si female. Yan. Tapos, pag nagdagdag po ulit, ang susunod na candidate si non-white. 84-84 na. Oops, lampas na. Lampas na yun sa minimum AIC natin, yung pinakahuling variable. So, wala na. No more variables added. Tapos, sinamarize ni Aryan, kaya ito daw yung mga pinasok na variable hanggang female. And then we have some regression outputs. Okay. R squared, adjusted R squared, predicted R squared. And then we have the root mean square error, the mean square error, and the mean absolute error. Ano ba yung root mean square error na to? Well, these are measurements of errors, guys. Itong mga to. No? Of course, the lower, the better. Si root mean square error, madali lang yan. Yung mga errors, square mo lang, kunin mo yung average, kunin mo yung square root. Okay? Ganun lang yan, guys. Root, square root. Mean, square error. Diba? Kinuha mo na yung squared errors muna. Squared errors, tapos kinuha yung average niya, tapos kinuha yung square root. Okay. Alright, ANOVA, guys. Very popular sa atin to. Ito yung SSR, SSE, SST, degree of freedom 7 kasi, bakit 7 guys? Kasi 7 regressors. Okay, ito yung N minus K minus 1. Okay. Ito yung N minus 1. Ito yung MSR, MSE. This divided by this, F stop. Alam natin yan. Okay. P-value is less than 0. Okay. Practically 0 pala. So that's less than 0.05. Therefore, ano yung conclusion natin? Ida, ano yung conclusion natin sa ano yung inference natin dyan?
sir. Sorry.
Ano yung inference natin dito? Anong conclusion natin dito? P-value nito is 0.0000. What's our conclusion?
Sorry, sir. I didn't get to sunod kanina kasi nagka-crash po yung R ko.
Sige, sino pa? Pau, ikaw, Pau. Anong conclusion natin dito?
Not sure, sir, but
Ano ba yan? Guys, please, naman. Dapat, di ba, ang conclusion natin dyan, ano? Reject the null hypothesis. Ano yung null hypothesis natin? B0 is equal to B1, is equal to B2, is equal to B3, hanggang is equal to B7. Okay guys, non-negotiable yan ha. Dapat at this time, ano na tayo eh, advanced regression na tayo guys ha. Okay? Mga advanced na mga tanong yan guys. Ang null hypothesis natin dito sa ANOVA is equal yung mga ano natin, mga coefficients starting with B0. Bakit B0? Kasama si intercept, guys. Hanggang is equal to B7. Kasi 7 regressors is equal to 0. So lahat daw yun ng mga coefficients is equal to 0. Okay? So we reject that. Ibig sabihin nun, there's strong statistical reason to believe that at least one of them is not equal to 0. Okay, so paano natin malalaman kung sino hindi mga 0 doon? Ito. Sa mga t-test natin, sa individual coefficients natin. Okay? Ito yung mga values na, coefficients. Okay? And then yung t-values and then the significance. Okay? Tingnan nyo guys. Merong pumasok na 0.10. Ibig sabihin nun, medyo iba yung parameter ng p at saka iba yung parameter ni AIC. Si AIC, ang ginamit niya, for as long as bumababa yung information criterion, pasok ko yan. Okay? Alright. So, sino mas magandang model, guys? Ito o yung 6 kanina?
Yan, sir.
Okay, based on p-value, mas maganda yung 6. Based on AIC, mas maganda to. Okay? So, however, as to the question, sino yung mas maganda? Well, we have to conduct further tests. No? Actually, alam na natin yung answer. Kasi itong model na to, nakasama si female. What did we find out, guys? May problem sa multicollinearity to, di ba? Masyadong highly related si female at saka si female education yata. Or si female experience. They are very highly correlated. Kaya remember guys, what we're doing is just model building pa lang tayo. Ano yung next step dito? Diagnostics. Okay? Alright? So hindi enough guys, as sa paper nyo hindi enough na sasabihin nyo lang ko yung ano model. Kailangan you should conduct diagnostics for that. Okay? So tapos na tayo guys sa forward, mag-backward naman tayo. Backward. And sometimes guys, hindi pareho yung result ng backward at saka ng forward. If that happens, I've seen several times na ang output ni backward regression iba kay forward regression. So parang magfa-further test ka pa kung sinong mas maganda doon. Pwede kang mag-ANOVA. No? Remember guys, nag-ANOVA tayo in comparing to models. We can do that here. Kung magkaiba yung ano nila. For as long as dapat pareho yung, ano dapat yung pareho? Denise, ano dapat yung pareho? For the models to be comparable.
We're all on the same side.
Ano? Denise? Nicole? Ano?
Apa, sir?
Anong answer doon? Kunyari, ibang output yung binigay ni forward regression kaysa kay backward regression. Pwede ba natin ma-compare yun?
Hindi
Answer?
po.
Pwede, guys. Diba? Pwede. For as long as pareho yung dependent variable nila. Diba? Hindi lang natin pwede i-compare yung dalawang models kung iba yung dependent variable ng isa. Kunyari, isa wage, isa log wage. Hindi pa pwede yun. Kasi you're just comparing apples and oranges. Pag pareho yung independent variable sila, kahit na magkakaiba yung independent variable sila, pwedeng i-compare yun. Okay? Alright. So let's go to backward regression. Pareho lang yung model na to. Actually, hindi natin kailangan i-run to kasi Existing pa yung object na yan. Andiyan pa yan, no? Andiyan pa si model. Andiyan pa yan, no? If I go down, model is still there. Saan yan? Okay. Anyway, andyan siya. Na-generate na natin yung object na yan kanina. So what we're going to run is just this. So sa backward, guys, ang command OLS step backward using p-value. Parang pareho lang to dun sa kanina sa forward. Pinalitan na natin yung forward ng backward. And then here, P, ano naman to? Removing. Kanina P enter, no? Ito P remove. Tatanggalin natin dapat yung ano, yung variable kung hindi siya nag-fit dun sa 0.05 na P value. Okay, let's run this. Okay, so we have this. Elimination, guys, ang rin-report nito. Kanina, sa forward, yung entering. Ito yung mga ini-eliminate. So dito, 5 yung eliminated, no? Okay, 5 yung in-eliminate. Sa forward P method, ilan yung pinasok? Guys?
6 yata, sir, or 7?
6. Tama, 6, no? Ito naman, 5 yung tinanggal. Forward P value ang ginamit natin. So sa forward, 6 yung pinasok. Sa backward, 5 yung tinanggal. Ibig sabihin, pareho lang sila. No? So in this case, si forward ni P at saka si backward ni P, pareho lang. You can check that. Hindi kasama kay forward si female. Dito kay backward, hindi din niya sinama kasi tinanggal niya. Okay? Clear yan, guys?
Yes.
Okay,
Yes, sir.
Yes, sir.
Okay, thank you. So ito, naran na natin to, no? Na BW fit. Ano naman to? AIC naman, guys. This time, AIC yung gagamitin natin. Ang dali lang, guys, ang code, oh. Backward AIC. Forward P, forward AIC. Backward P, backward AIC. Pareho lang yung OLS stepwise regression. Okay? And these are just objects that we created by choice lang. So you can choose, of course, different names for that. Okay, let's run the whole code. Ba't ang bagal mag-run ng R ko ngayon? Kanina, mabilis to eh. Let me just wait. Yan. Okay? Pag AIC naman, guys, anong difference ng backward ni P at saka backward ni AIC? Mas maraming tinanggal, guys, si P. No? Lahat ng mga hindi pumasok dun sa 0.05 criteria, tinanggal niya. Ito naman, okay, so tinan niyo yung backward elimination ito, guys. Nagsimula sa full model, tinanggal niya ilan? 4, no? So magkaiba si backward P at saka si backward AIC. Parang yung sa taas din forward P at saka forward AIC. Okay guys? Clear?
Here.
Anong difference? Pareho ba si forward AIC at saka si backward AIC? How many variables were entered in forward AIC?
7 po.
7. How many variables were deleted from backward AIC?
4.
4. So pareho lang sila ng result, no?
Yes.
Tama, guys? Pareho lang, no? In this case, magkapareho yung forward ni AIC at saka backward ni AIC. And then you can plot this. You can include this in your assignment or in end reports. Pinapakita kung paano tinanggal yung mga variables. Okay? Non-white, non-unit experience, etc. Okay. Then, this also gives us the intermediate steps. Parang sa taas lang to, pero AIC to, no? So, ibig sabihin, papakita niya kung paano tatanggalin AIC na backward. Okay, so nagsimula guys kung sa taas, sa forward guys, nagsimula sa 0 base, ibig sabihin walang regressor. Ito, lahat ng regressor kaagad. No? Yan, lahat kasama. So again, titinan kung anong tatanggalin, isa-isa. Kung tinanggal natin si education, 8536 yung AIC. Diba? Tama ba guys? Wait. Ano ba to? Backward to, no? Okay. So everything here, 84, 88. So pag tinanggal natin si non-white, ano mangyayari, guys?
Bababa po yung AIC.
Oo. Pag tinanggal natin si education, tataas pa. 85-36. Mas mataas pa kaysa base model natin ngayon. So not a good idea na tanggalin si education. So first candidate, non-white experience. Okay. I'll go through this quickly. X, ibig sabihin, variable removed. Okay, and then etc. etc. Ganun din yung kwento, guys, step by step, no? Step by step, nagtatanggalan ng variable hanggang sabi niya, pagdating dito sa step 4, ito na yung model natin. Pag tinanggal pa natin si female, ano mangyayari? Tataas si 80, kasi si female kasama dito no? Pag tinanggal natin si female, tataas si AIC, magiging 84-84. Currently, 84-83 yan. Kaya, no more variables removed. Okay, and then sinasummarize kung ano yung mga tinanggal na variables. And just like above, yung model output natin, ANOVA, and then ito na yung mga regressors natin na kasama si female. Even if ang p-value is 0.098, even if it's greater than 0.05. Okay? Ang naging criteria yung dapat bumaba yung AIC. Kaya ang lesson dyan, guys, hindi foolproof na pinakamababang AIC. Yun na yun, ano? In some cases, okay na yun. Pero we have to be very careful. We have to check kung may hindi ba naging significant doon. Okay, so you have to look at the model. Tapos kunyari, dapat tanggalin yung variable na yun, then we will have to choose the model without the variable with the p that's higher than 0.05. Okay? Kahit na mas mataas yung AIC ng konti. Kuha nyo, guys. So parang may compromise ng konti, ano? Alright. Ito naman, guys. Stepwise, anong ginagawa sa stepwise? Magsisimula mo na yan sa base na parang forward, wala mo nang regress. Tapos isa-isahin, papasok mo na, pasok siguro, tapos kung baka pwedeng tanggalin, magtatanggal. So pwedeng magtanggal, pwedeng magpasok ulit. Okay, stepwise regression using P method. Run natin. Okay. So dito sa stepwise na to, wala siyang tinanggal. No? Lahat inad lang niya. And it's the same as your forward p-value. Okay? Pero tingnan niyo yung title dito, yung head. Added, removed, ibig sabihin, pwedeng magtanggal, at saka pwedeng magbawas. One at a time. Any questions so far, guys?
None, sir.
Okay.
None po, sir.
Thank you. Now, next is stepwise using AIC. Ganun din to. Okay, andito pa pala yung results namin. So take note, OLS, step, both. No? O nga pala, I forgot to point out. Pag stepwise regression, both siya. Pag forward, forward. Pag backward, backward. Pag stepwise, both. Okay? Pareho. Okay, and it turns out that ito yung lumabas. Panay addition din, walang tinanggal. Okay? So, pito siya. Pito yung significant variable. Pito yung variables natin as regressors. Okay? Pareho lang siya dun sa stepwise, sa forward na AIC, backward na AIC, tsaka stepwise na AIC. In this case, nagkapare-pareho sila. Lagi bang pare-pareho yun? No, guys, no. Sometimes nagkakaiba-iba silang answer. Okay, and then we can plot yung both natin. Plot. Okay, yan. Ganun din, no? Okay. Both direction. In this case, lahat, alam natin na based on the table above, lahat to inad. Okay, nararaan nyo ba, guys, on your own?
Yes, sir.
Alright. Ito naman, guys, no? All possible subsets. Tingnan nyo. I just want to point out something. When we regress wage, pwede namang isa lang yung ano eh, di ba? Isa lang yung independent variable natin. Education lang. O kaya pwedeng si experience. O kaya pwedeng si female lang. O kaya pwedeng si non-union times experience lang. Okay? So we can have a regression model where your explanatory variable is just one. Or pwedeng dalawa. No? Sige, combine natin si education times experience. In fact, ito yung unang-una natin na pinag-aralan, if you recall. No? O kaya si education at saka si female. Education times non-white, etc., etc., etc. So what am I driving at? Ang daming pwedeng combinations ng model, choosing from these 11. Okay? Ilan yung possible combinations? The possible combinations, guys, ang formula niyan, 2 raised to the k minus 1. Oops. Dito ko isulat. 2 raised to the k minus 1. Okay, can you see, guys? Can you see what I wrote in the console? All right. Ilan yung k natin? 2 raised to the 11 yung regressors natin, minus 1. Oh, yun. A possible 2,407 models. Ang assignment, Pau? Pau.
Ano po,
Chu?
sir?
Ang assignment mo, i-generate mo lahat yan, ha?
Ang dami naman, sir. Baka tapos na yung term, sir. Di ba
Anong
tapos?
term? Tapos na yung ano, graduate ka na siguro.
Oo, sir.
2,407 regression models, guys. That's too much, no? Anyway, sige. Let's just generate that for purposes of educational purposes, no? Ang tawag dyan, guys, all possible. And kaya tinan yung code nito, step all possible. Pag yan ang kinode natin kay OLSRR, okay, let's call it mod compare, no? Model compare. Okay, let's run that. Run natin yan. Okay. That will take some time, guys, kasi 2,407 yan eh. Hintay-hintayin natin. Okay. May tapos na sa inyo, guys? May nakatapos na? Wala pa. Taking some time. Yeah, okay. How about you guys? Were you able to generate the output?
Akin wala pa, sir.
Wala pa?
Wala pa, sir.
So, hintayin natin ha. Tell me kung na-generate na ninyo ha. Dami kasi yan eh. Diyan na, guys?
Yes, sir.
Meron na ha?
Meron na.
Okay. So, tingnan natin yung output dito, guys. No? Ang linagay niya dito sa first column and third column. Index muna kung anong parang ID ng model. No? If you notice guys, yung N, these are the number of regressors. So inuna niya yung tigi-isa. Okay? Pansin nyo guys? Yung tigi-isa muna. Tapos sino inuna niya guys among the possible models na only one regressor? Sino inuna niya?
Education po.
Bakit education?
Pinakamababa po na AIC.
Yes, inuna niya yung pinakamaganda dun sa ano na yun, sa subset na yun. Subset ng isang ano lang, isang regressor lang. So either ginamit niya si adjusted R squared o si Mallows. Okay, clear guys? Tapos sa pangalawa naman, ang dami nito. No? Kasi combination ng 2, madami yan. No? So inuna din niya si pinaka-best sa subset ng 2. Okay? Etc. 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 guys. Okay? Unfortunately, nakatibol yata tong ano, tibol yata tong kaya hindi niya nag-omit siya, no? Pero check muna natin. Paki-add nga guys, what's 1881? 1881 plus ito yan guys, 1881. Pareho ba tayo? Omitted 1881 rows plus omitted 1881 rows. Ibig sabihin hindi na niya pinakita. Plus, ilan na yung models na nakaprint dito? 166. Diba? Ayan o. Index number 166. So, 166 models dito plus 1881 na omitted rows, hindi niya pinakita. Ilan to, guys?
2047.
2047. Looks familiar, guys? Naalala niyan? Yung kanina, 2 to the 11 minus 1, di ba? 2407. Tama. No? Tama. Nag-generate nga talaga si R ng 2047 models. Alright? So, a better way to view this is, i-convert natin, guys, si mod compare. Ito yung si mod compare. I-convert natin siya as data frame. So, sige, i-run natin to. As data frame, okay, so I think it's a better presentation. So andun yung predictors, R squared, adjusted R, mas kompleto yung ano niya. Mas kompleto siya sa pag-present. Hanggang may SBIC, SBC, etc. Okay? Okay, so ganoon din pag inad mo tong hindi natin alam kung pang ilan to. Ano? Okay, hindi naka-state dito. Pero ito yung index. Okay, then i-plot natin, guys. Plot natin si mod compare. Okay, what do you see here? Sometimes, guys, pag R markdown kasi very limited yung ano, no, masyadong hindi natin ma-enlarge to eh. So what I would do is sometimes I would page up. Andito pala. Sorry. Page up. So, oops. Yan. Arrow down para yung latest na ano na code. Dito ko siya i-run, guys, ha. Control enter. Ayan. So mas maganda dito kasi magge-generate siya ng ano na pwede ma-zoom, no? Okay. Alright. So ano tong mga ano na to, guys, yung plot na to. Okay, pinapakita dito, guys, yan nyo ha. Kunyari, based on Akai key. So sometimes it's best to copy this sa Word para medyo ma-expand. Okay? What do you see here, guys? The number on the x-axis, these are the number of regressors. Hanggang 11 yan. And then you'll notice there are triangles. No? Ang ibig sabihin yan, based on Akai key, kung isang regressor lang, model 1 ang best. Paano ko nalaman? Yung triangle na 1 na yan, guys, that refers to index 1 dun sa model. Kuha, guys? Hello?
Sir.
Yes, sir.
Okay, thank you. So ito, kunyari itong 9 na to, hindi lang natin masyado makita. I think it's 1981. So kung 9 regressors guys, ang pinakamaganda si 1981. Ibig sabihin, nung puntahan nyo yung model na yon, yun nga yung best doon. Ito, tingnan natin to guys. If we're going to use 3 regressors based on AIC, sino daw yung pinakamaganda model guys?
67th model.
67, correct. 67. So, punta natin si 67. Tingnan natin si 67. Asan na yan? Nandito. Okay, let's see. 67, yun. 67 is where 3 variables start, di ba? Oh, classify si North na ni R. Right? So, kung 3 variables ang gagamitin, si education, si experience, at si female education, yun ang best. By virtue of having the highest, this is adjusted R squared, this is the Akaiki ba to? Ito yata Mallows, ano ba to? Mallows, ano siya? Mallows CP, okay? Among the 3 models, siya yung pinakamaganda. Okay? All right, so let's leave that. Are you following guys? Okay lang ba yung pace ko?
Yes, sir.
Okay, kasi kaya ako naman ina-accelerate yung pace kasi alam ko naman na kasi you have the decoder already. So, ang suggestion ko, medyo i-review siya guys para hindi nakakalimutan. Okay. So, we can also plot this. Naplatan natin tong Now, yung best all possible, lahat binibigay sa atin yung 2047. Pero, hindi naman natin kailangan yun. Kaya siguro pwede natin hanapin na lang yung best subset. Kaya meron din ganun. OLS, step, best subset. What this will give us is, kunyari, kung isang regressor lang, sino yung pinakamaganda? Kung 2 regressor, sino yung pinakamaganda? 3 regressor, sino yung pinakamaganda? Parang yun dun sa may mga arrow dun sa kanina sa diagram. Okay guys, clear? Clear ba itong best subset, no? Best subset, dito tayo. Ito. Best subset, run natin. Mode compare pa rin tinawag ko sa kanya. Matagal ng konti. Tagal naman. Naka-dead pa siya. Nag-output na sa inyo, class?
No, sir.
Yan na. Okay. Ito yung output niya. No? Alright. So ito yun guys. Model 1 to 11. Bakit model 1 to 11? Kasi subset siya ng 2,407 models. Wherein pipiliin niya kung isang regressor, 2 regressor, hanggang 11 regressors. So, sasabihin niya, ano yung predictors kung isa lang, education. Kung 2, ito yung pinaka-best. Of course, sa 11, lahat yun. Wala naman tayong option kundi yan lang. Diba? Alright, so going down, guys, ayan, may tabular summary ng ayan, no? Okay? May tabular summary tayo. So for example, kung yung model 11 for example, lahat, of course, expected na siya yung pinakamataas na R squared. Pero alam naman natin na that should not be the basis. In fact, sa adjusted R squared, talo pa siya ni 8 variables. No? Okay, so it doesn't mean na more is better. No? In fact, less is better sa regression. And then, based on Akaiki, sinong pinakamaganda, guys? Based on Akaiki, C7. Ito, 84-83. Based on Malos, CP, ito din, 7 din. Based on SAWA, Bayesian Information Criterion, si SAWA, ito din, no? Tapos si Schwartz, kay Schwartz medyo na iba, no? It's, ano siya, si Schwartz, 5 yata o 6. Okay? And then there are other methods. Kay Amamiya ito. 7 din sa Amamiya. So maraming, pati si HSP, no? Maraming consistent with 7. Pero again, guys, we have to test that, no? I-check pa natin yan. At least sa modeling, sa model selection, meron na tayong dalawang candidates. Either yung 6 o yung 7 variables. Ang difference nila si female. Okay, mapaplot din to, guys. Mapaplot din siya. Okay, but I won't anymore explain this. Yun lang din naman yun. No? So for example, based on R squared, alam natin, based on R squared, pinakamaganda yung 11. Based on adjusted R squared, hindi na banda dito. Ito yata. Based on Akaiki, it's the lowest. It's somewhere here. Ganun din si Malos. Okay? Etc. Graph lang naman. Okay, so that ends, guys, our discussion on model selection. Sabi natin, nag-stepwise regression tayo. Si stepwise, actually, tatlong klase yan. Meron tayong forward, meron tayong backward, meron tayong si stepwise mismo. So we learned how to distinguish between step forward and backward. Sabi natin, pag forward, magsisimula sa walang regressor, magdadagdag isa-isa. Pag nadagdag na yon, hindi na pwedeng tanggalin yon. Si backward naman, magsisimula lahat regressor, magtatanggal isa-isa based on p-value, tatanggalin, or AIC, depende dun sa model. Pareho ba lagi yung nila? Outputs, hindi. Sometimes may difference. But usually, nagpapareho sila. Okay, so pagkatapos nun, guys, pag na-select na natin model natin, sabi natin, itong stepwise regression, magandang gamitin yan especially kung marami tayong variables talaga. Tapos kasi kung hindi tayo magsi-stepwise, hindi natin alam baka may tinanggal dun sa model, sa final model. Kasi di ba pag nag-linear model tayo, automatic tatanggalin niya yung sasabihin niya kung sino yung mga hindi significant lahat, no? Okay, ang tanong doon, anong method ang ginamit doon? O kasi baka kung i-check ko pa to for stepwise, either forward or backward, baka may mga tinanggal siya na hindi pa significant. And that happens, guys. Kaya mas maganda, after running the model, mag-stepwise tayo. So pag nag-stepwise tayo, naka-determine na tayo ng for purposes of example, sabihin natin, lahat ng mga forward, backward, at saka stepwise, pareho lang yung choice. Is that finished? Hindi pa, guys. Pupunta na tayo sa diagnostics. Check na tayo for multicollinearity, pupunta na tayo kay heteroscedasticity, pupunta na tayo kay autocorrelation kung time series, pupunta na tayo sa residuals, tingnan natin kung may heteroscedastic pa siya, etc., etc., before coming up with the final model. Okay? Clear so far, guys?
Clear, sir.
All right.
Yes, sir.
Kindly open the other file. Ito, pakibukas na to, no? Ito na yung structural form. Okay? Sa structural form, kasama na rin natin dito yung diagnostics. Ang structural form, guys, yung interpretation ng ng meaning ng coefficients. Kasi, paano kung nakalog yung variable natin? Kunyari, yung sa model natin, hindi wage, log wage. Paano natin i-interpret yun kung nakalog yung wage? O kaya si education, nakalog din. So how can that be? So yung structural, guys, tells us kung ano yung form ng model natin. Kung nakalog ba siya o naka-reciprocal ba siya. Remember, yung mga natin, x values and y values, pwede yung naka-square yan, pwede naka-square root. Ang hindi pa pwede naka-square root, naka-over, 1 over or may ratio is your coefficients, yung mga parameters natin. Okay? Alright, so ito guys, I hope you have already installed this. Na-install nyo na ba to? Sa diagnostics, marami tayong magagamit dito. No? Si Broom, I think we have installed this before. Si CAR, comprehensive applied regression, correlation plot, forecast, GG Ally, GG Fortify, GG Plot 2, GVLMA, etc. etc. Okay? I hope na install nyo na. Kanina nabigyan ko na kayo ng instructions. Na-install na ba, guys?
Yes, sir.
Okay. Sige. Tapos paki-import na, guys, si OLK. Si OLK, pinost ko yun sa ano natin, sa module natin. Kindly import that, OLK. That's output, labor, capital. Okay, na-import na, guys. So you should okay, ignore guys yung mga log dito Kung na-import nyo na siya guys, dapat ang lalabas yan si output, si labor, at si capital. Okay, ito kasi ginawa na namin sa kabilang class. Anyone who hasn't uploaded the file, imported the file? Pakisabi nga kung na-import nyo na. Mag-yes nga kayo, guys.
No, sir.
Hindi pa? Hindi pa. Sige. Okay. Thank you for informing me. Kindly import the OLK file which I shared with you a while ago. Okay na, guys?
Okay na, sir.
Okay na? Alright, good. Okay. Sana na-install nyo na itong mga package ito So, i-view natin si OLK. Kung hindi yung pa na-view, paki-view. Okay. Sa akin, ang lalabas guys, may nadagdag na tatlong variables kasi ginawa na namin ito kanina. But for you guys, may output, labor, capital. So, these are in dollars, I think. So 3 million or 38 million something dollars.
Yes, sir.
Okay, labor, capital. Okay? So, ang gagawin natin dito, from economics guys, well established naman yung fact that output is dependent on labor and capital. So in this case, i-regress natin si output using labor and capital. Okay. First, tingnan natin yung structure natin. Okay. Labor capital. Again, ignore guys yung log output Okay, so you have 51 observations, 3 variables, si output, si labor, and capital. Okay, then now, oftentimes in finance or in econometrics, you'll see that they would get the log of variables. Bakit kinukuha yung log? Kasi yung log, pag linolog nyo siya guys, it helps scale the values. Remember, take a look at this, mga mga tens of millions yata. Ito naman hundreds of thousands, ito millions din. Pag linog natin yan guys, bababa yung values yan. So it becomes easier to deal with. Especially dati, yung computing power was very, very expensive. This made sense, no? Pero ngayon, medyo hindi na kasi kahit naman halos pareho lang naman ang speed kung hindi mo siya ilog Yung si interpretation nga lang, may mga pros and cons, no? Kasi kung parehong log, actually ang daling i-interpret. Ngayon, pag hindi parehong log, yung isa hindi log, yung isa log, medyo may konting ano lang naman, konting difference. Alright, so ito na guys, paki-ano na to, yung code na to. Paki-run to, kasi ang gagawin natin dito, yung OLK, mag-create tayo ng object. Sa OLK, ang tawag natin, OLK log output, kukunin yung log ni output. Kukunin yung log ng labor at saka yung log ni capital. Okay, tapos i-run nyo guys, run, and then you'll have now the same variable na data set na OLK na meron ng mga log output, log labor, log capital. Okay, kindly run this guys. Okay. Okay, so far guys.
Okay na, sir.
Okay na? Okay, so
Okay na.
na-generate. Make sure na na-generate yun yung OLK Okay, yung OLK natin, kasama to. We could have opted to create another object na mas maganda nga sana yun na hindi na yung ano na lang, yung log output, log labor, log cap. Siguro next meeting na lang, no? Kasi malapit na mag-time. Gusto kong umabot tayo dun sa inabot namin sa kabilang class. Alright, ito. This is a very, I like this, yung correlation matrix. Using GG pairs. May nag-problema lang kami dito sa isa dito sa GG pairs na to. Pero ito muna guys, you can use the pairs function sa base R to, pairs. So tilde, so i-pair wise na si log output, log labor, at saka log capital. Data from OLK. Okay. Ang i-run lang muna natin guys itong pairs. No? So kindly run it, control enter. Yan. Okay? So pairs will give us the pairwise comparison, yung scatter plot ng variables of interest. So log output at saka sa log labor, okay siya, no? Highly correlated. Maganda. Maganda tong i-model kasi gusto natin si dependent variable natin highly correlated with your log labor. Ibig sabihin nun, kayang i-explain ni labor si log labor, si log output. Ganun din kay log capital, no? Here. Ang problema natin, itong si log labor at saka si log capital. Ayun. Related din sila. So sabi natin, that might yield to what problem, guys? What problem in multiple regression? Hello? Anong problem?
No problem, sir.
Ano, no?
No problem.
May problem nga eh. Ano yung problem? Anong tawag natin doon sa problem na yun?
Multicollinearity.
Multicollinearity. Kasi mag-aagawan sila ng pag-explain kay log output. So there might be a problem with your variance inflation factor. Alright, ito naman i-run natin si GG pairs. I like this better si GG pairs. Mas powerful to. Galing to kay GG apply, GG ally, or GG45 yata, I'm not sure. Yan, okay? Tingnan natin. Yan, okay? Yan, yung pairs, no? So, sinama niya yung value sinama niya yung plot, tapos sinama din niya yung correlation. Okay, pwede natin yung dito yan, no? Oops. Ito pala. Yan. Yung arrow down, pwede natin para makopy natin yung control enter. Yung mga plot, minsan mas gusto ko guys, kahit i-run nyo sa R markdown, pero maganda rin i-run nyo siya dito sa sa console para you can zoom natin, okay? And then you can copy this or pag zoom natin, zoom, come on. Okay, naghang. Naghang siya. Kasi pag zoom natin yan guys, dapat maglalabas na yan ng isang document. Okay, anyway. So, tingnan natin guys We're interested in log output, log labor, log capital. Since hindi naman natin gagamitin to, sana nag-create na lang tayo ng isang object na itong tatlo lang. No? We could have done that. Para mas focus yung natin. Alright, tingnan natin. Okay, si log output, log output, and log, natin dito, log output and log capital. Correlation 0.973, ang taas. Very good, kasi related si, hindi, wait. Tama, log output and log capital, related si dependent variable natin kay independent variable. Okay? How about si log output kay log labor? Ito, good, ang taas din, 0.971. Okay, magandang regressors na yung log labor at saka log capital kay log output. No? Okay, however, sabi ko nga kanina, 0.96 yung correlation ni log labor at saka log capital. We might have an issue there. Okay? So, ibalik ko na to. Alright, let me X this. Okay, nagka-problema ako sa code na to. So, iwan muna natin to. I have to check the syntax. Kasi what I was doing here was just to plot yung tatlong log. No? Yung tatlong log lang by using the columns function. Pero nagkaka-syntax error ako. Maybe it would have been better for us to create OLK, log OLK. Okay. Anyway, I leave that to you na lang. No? Okay, so magre-regression na tayo, guys. I-regression na natin si log output with log labor and log capital. Okay? So, summarize natin. Okay, and then we can run this. Let's first run this. Control Enter. Yun. Ito yung regression output natin. Okay, so ito yung formula, ito yung code na binigay natin. Okay, may summary tayong residuals dito. Then you have the individual coefficients, intercept, log labor, log capital. It looks like na highly significant sila, no? Significant at 0.001. Okay? So, okay. Ano yung equation natin dito, guys? Ano yung model natin? Considering na significant naman sila lahat, yung model natin, paano, guys? What's our model here? Guys, ano? Log wage is equal to this one plus ano?
0.4.
Yan, okay?
0.4 log labor plus 0.521 log cap.
Yan, log labor plus this one. Okay, yeah. Okay, so my plus error. Okay, so what do we, how do you interpret this now? Okay, take note, guys, that this is a log model. Nakalog yung dependent variable natin, nakalog yung mga independent variables natin. Ang tawag dyan, log, others call this double log, or they also call it log linear. No? Log linear model. So if you see this, guys, log, ibig sabihin, yung dependent variable natin nakalog, lahat ng independent variables natin nakalog din. Pag lahat ng independent variables nakalog, then ang tawag doon, log or double log or log linear. Okay? All right, how do we interpret now? This is our model. How do we interpret this? Okay, again, yung intercept, guys, that's the value of your log wage when your log labor and log cap are all equal to 0. Tama? Tama ba, guys?
Yes, sir.
Yes, sir. Kaso nga lang, baka magka-problema tayo dyan kasi ang log will never be equal to 0. Yun. Yun. So, paano kaya interpret yan? Okay, so hindi natin naabutin, pero let me just tell you how do we interpret this. Ano yung 0.48633? Dati, paano natin interpret yan? For every 1 unit of log labor, there's a corresponding 0.46833 increase in log output, di ba? Right, guys? Ceteris paribus.
Yes.
But is that the interpretation? Hindi na. Hindi na, guys. Kasi nakalog yan. Pag pareho sila nakalog, okay, ang interpretation na yan, magiging ano na, for log model, magiging ano na siya, a 1% change in your IV will result to a B% change in your DB. Okay, so how do we read that? A 1% change in log labor a 1% change in log labor will result to a 0.46833% change in your log output, all things considered equal. Kuha nyo, guys? Kung ano man yung B na to, guys, lalagyan natin ng percent. So 1% change kay log labor means, time na ba? Malapit na mag-time. 1% change in log labor means 0.4863% change in your log output. 1% change in log capital means 0.52128% change in your log capital ceteris paribus. You follow, guys? Follow? Follow?
Yes, sir.
Okay.
Yes, sir.
We were able to write the regression equation. We were able to interpret the coefficients. No? Now, again, it doesn't stop there. Kailangan i-check natin yung residuals. No? Ito last na before we go. So we have this partition by yung rows natin, 2 rows and 2 columns. Okay, you use this code pag inaan natin yung residuals. So sa lesson na to, guys, titingnan natin yung how we look at the residuals also after our model. So we have 4, actually 5 to, no? 5 yan. I'll just tell you how next meeting. So tingnan natin to, guys, kamusta? May problema ba tayo dito sa sa homoscedasticity natin? Okay, visually parang okay naman, no? Hindi naman siya nagfa-fan out, no? Hindi siya nagsa-spread out. Dito mukhang may problema tayo sa normality kasi may mga mukhang outliers tayo, no? Ito si 32 at saka si 8. Ganun din dito, no? Cook's distance will tell us of the influential points. Ibig sabihin influential points. Ito si 32, 19 at saka 27. Pag tinanggal natin yung points na yan, guys, pag tinanggal natin yan, mababago yung model natin. Pati dito, guys, standardized residuals ito. Okay, so this is where we continue next meeting. Okay, so itutuloy-tuloy na natin to, guys. Okay, and then I'll be recording another lesson. This time it will be yung panel regression na yung susunod, no? Okay, so kindly look at this, guys, para next meeting. Kung pwede, pakiran nyo na. Para next meeting, discussion na lang tayo. Okay, so andyan na naman si AIC, BIC. Nagko-compare tayo dito ng mga models, guys. We have done this in the past. We'll just look at them again. Okay? So, all right. So, that's all for the day, guys. Thank you so much for
Thank you, sir.
attending. And then we'll meet on Thursday. May
Thank you,
na-late
sir.
ba? Okay,
Thank
thank
you,
you.
sir.
And the late
Thank you,
comer.
sir.
Alright, sige. Salamat, guys.
Sir, si Chelsea Pexon.
Sino?
She's Chelsea Pexon.
Mm-mm.
She is present, pero her internet kanina wasn't stable, so I don't think she got to tell you.
Okay. Pexon.
Yes, sir.
Sige, andali ah.
Sir,
Yes.
Adrian din po, sir.
Adrian. Andali. Where's my... attendance? Sino? Pexon.
Yun, si Joanne. Yes. Thank you,
Okay.
sir.
Alright. Sino isa?
And si Adrian de Parana.
Adrian.
Hi, sir.
Lagi ka na lang late, ha?
Sorry, sir.
Awesome Adrian, ha?
Thank you, sir.
Okay, thank you. Marami ka ng absent, Adrian.
Sir, isa lang po yung absent ko, sir.
So lang ba? Last time, nag-check ako na attendance, wala ka rin, eh.
Sir, yung last week, last meeting po ata, sir, di po ako nakapunta talaga, sir. Run out
Sige.
talaga, sir.
Yan.
Thank you, sir.
Send ko na, sige. Okay.